Chapter 1.1 Read-Along, Part 3, Energy and Systems. Energy is an important concept that is difficult to define. Energy is a measure of a system's ability to change or create change in other systems. A car at the top of a ramp is able to move because it has energy due to its height on the ramp. The car's increase in speed as it moves is a change in the system that could not occur without energy. Energy can appear in many forms, such as heat, motion, height, pressure, electricity, and the chemical bonds between atoms. The key to understanding how systems change is to trace the movements of energy between objects and also between various forms of energy. This diagram is showing different forms that energy can take and different ways that it can transform between different types of energy. The stability of systems. Systems in nature tend to go from higher energy to lower energy. A system at higher energy is often unstable, while a system at lower energy is more stable. The car is unstable at the top of a ramp where its energy is greatest. It will naturally move to a more stable position at the bottom of the ramp. Creating change. The stretched bowstring on a bow is another example of a system that has energy, as shown in Figure 1.9. Released, the string springs back to its unstretched, stable position. The bow uses its energy to change its own shape. It can also create change in the arrow. While the bow and the bowstring move from high to low energy, the arrow moves from low to high energy. The energy originally in the bowstring is used to change the speed of the arrow. Energy can create macroscopic and microscopic changes to systems. The changes in the bow and arrow are macroscopic because they can be directly observed. If you shoot many arrows one after another, the bowstring gets warm from the heat of friction. This warmth comes from energy flowing between atoms at the atomic scale. Let's talk about models. An example system. Consider the following system. A stretched rubber band is used to launch a car along a track that is straight for a distance and then turns uphill. If the rubber band is stretched more, the car has more speed. If the car has more speed, it gets higher on the hill. How do we explain the relationship between the height the car reaches and the speed it has at the bottom of the hill? What is a model? Explanations in physics typically come in the form of models. In physics, a model is an explanation that links the variables in a system through cause and effect relationships. An example model. Figure 1.10 shows a model of the car and ramp system. Launching the car gives it energy due to its speed. Climbing the hill takes energy. The car climbs only so high because it only has so much energy. Making the car goes faster gives it more energy, and this is why it goes higher. This explanation is a model that links the height and the speed through the idea of energy. This model is known as the law of conservation of energy and is one of the natural laws of physics. The model in Figure 1.10 is conceptual because it is not precise enough to predict exactly how much height the car gets for a given speed. In Chapter 3, you will encounter a more detailed version of the law of conservation of energy, and we'll talk about it more in the second semester of this class. These questions are going to be part of your homework. I will have them in the document on Veracross for you to download and answer in Notability.